Hello again, here's Miss Wesley. We're ready for Unit 4 Skill 2, which is focused all around determining triangle congruence. So this is our main focus of this unit, hence the name triangle congruence. So our essential question for today is going to be what methods can be used to prove triangles are congruent? And what we're going to talk about today is going to carry over through the rest of the unit. It's going to carry over through the rest of the year. And it, again, all relates back to what we know so far about rigid motions and the fact that if there's a rigid motion that can take one shape and map it onto the next, those two shapes must be congruent. So we're going to focus all around triangles for today and for a little while here. So go ahead and copy the essential question down. If you don't already, go ahead and feel free to pause the video. But it says, in order to prove triangles are congruent, we must prove a minimum of 3 corresponding parts, and those parts could be either sides or angles, are congruent. And what's most important here is that they have to be congruent in a specific order. So we're going to talk about what are the options for those orders that they could be found in. But again, we need a minimum of 3, either sides or angles, that are congruent, and they have to be in the correct order. And we're going to talk about the 5 theorems or options that you can use to prove triangles are congruent. So like I said, there's 5 ways we can prove 2 triangles are congruent to one another. I'm going to talk through each of the 5 of them here, and then we're going to look at some examples on the back. So the first one we have here, SSS, and that stands for side, side, side theorem. So when we refer to this from now on, we're calling it SSS, and you can use this theorem if you have all 3 corresponding sides, and you know those 3 corresponding sides are in fact congruent to each other. So for instance, based on the marks here, we know side AB is congruent to DE. I know side BC is congruent to EF. And I also know that side AC is congruent to DF. So if I look at my picture here and going around, I have side, 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 side. So because the 3 sides, corresponding sides are congruent, that would force the triangles to be congruent. And again, our method is side, side, side. The second method, SAS, and that SAS stands for side, angle, side. So it's really important here that it goes in that specific order. A side, an angle, followed by a side. So looking at this right now, I notice that side AB is congruent to side DB, so that's my first side. I notice that I have this angle here is congruent to this angle here, so that's where I get the A from. But I'm looking for another side. Well, notice that these 2 triangles both share BC. So since they both share that side's going to have to be congruent to itself. It's called the reflexive property. So that's where our third side, our third piece of information is going to come from. So if we look at the order of the pieces that we have a side, followed by an angle, followed by another side. And if I look at my other triangle, a side, an angle, and another side. So these 2 triangles are congruent by side, angle, side. Opposite of side, angle, side is ASA, which is angle, side, angle. And if we look at our picture here, I notice that angle A, and again I'm going to put an A there because it's telling me an angle, would be congruent to A prime down here. I have this little mark here in the middle to tell me side AB is congruent to side A prime, B prime over here. And these 2 marks on angle B is another angle congruent to angle B double prime. So if I look at my order, I see ASA and I see ASA, therefore leading me to the conclusion that these 2 triangles are congruent by angle, side, angle. Now, this one down here, AAS. So this is angle, angle, side. Notice the order is different. So when I go to identify my pieces here that are corresponding and that are congruent, I notice I have an angle at A congruent to an angle at X. They both have the same number of marks. I then notice that as I'm following along from A to C, I notice the next thing I run into is another angle, an angle at C, is congruent to this angle over here at Z. And after that angle, I notice the little tick marks to tell me that I have a side congruent to another side. So looking at the order, this time it goes AAS followed by AAS. Therefore, these 2 triangles are congruent by angle, side, angle. If you read it backwards and said they were congruent by side, angle, angle, side, angle, angle, so if you wrote this, that's okay. It's just angle, angle, side backwards, so that would still be acceptable. the last method that we have, and this one kind of is out on its own. It's called the HL theorem, which stands for hypotenuse leg. So this theorem can only be used with right triangles. Only with right triangles. And if you think about that, the word hypotenuse has to be in a right triangle. So if you don't see a 90-degree angle somewhere, you're not going to be able to use hypotenuse leg. So if you see a right angle, that's a clue that it could be an option. But it might not be, so it depends on the problem. So how this works here is you have to have the hypotenuses congruent to each other. So that would be the side that's across from the right angle. And in this scenario, I do. That would be BC is my hypotenuse, and in this scenario, it would be YZ or ZY. And as long as the hypotenuses are congruent and there's one additional corresponding leg congruent, so for instance here it would be AB is congruent to XY, that would be enough to say the hypotenuse leg theorem. And you might be saying, well, Miss Wesley, that's only 2 pieces of information. You set up above that we have to have a minimum of 3. Well, the third piece actually comes from that 90-degree angle. That's the third thing that they have in common. But since it's a hypotenuse leg theorem, we know that they would have to have a 90-degree angle in order to even use that theorem. So, looking back here, your 5 theorems: side, 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 angle, side, angle, side, angle, 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 side, and HL. Those are your 5 theorems that you can use to prove triangles are congruent. And we're going to take a look at some examples on the next page to help you identify which theorem you should use when. Okie dokie. And before we go into these examples here, side note, and a super big important side note. Let's see if I can even get like a highlighter or something going here. You will never, ever, ever, never, you're never going to use side, side angle or angle, angle, angle. All right? So sometimes students look at this, and read it angle side side. Yes, that would give you a bad word there. That's not the reason we can't use it. It mathematically does not prove triangles are congruent, and neither would angle, angle, angle. So if you ever end up in a situation like this where you have side, side angle or angle, 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 that's not going to work. So don't ever use those as triangle congruent statements. We can only use the 5 that we had on the front. And if we want to take a second and jot them down, we had side, side, side. We have side, angle, side. We have angle, side, angle. We have angle, angle, side. And we have HL. Those are the only 5 theorems that we are going to be using this year. So let's take a look at these examples. It says, for each of the following pairs of triangles, determine whether or not the triangles are congruent. If so, state the congruence statement and the theorem by which they are congruent. So the first thing you want to do is you want to look at what pieces are given to you. So for instance, I know that angle C and angle U are congruent, so I'm going to put a little A by them because those are an angle that I have. Then I notice angle T is congruent to angle V, and I notice I have a side here on the end, AT and TV. So looking at the order, I see AAS and I see that AAS. So looking at my choices here, that would qualify under angle, angle, side. So the first thing I would write is I need a congruent statement. So if I follow the orders of the letters here, and you could go in any order, I'm going to go in a similar order to the which I identified these. I would say triangle CTA is congruent. So I went CTA would be congruent to triangle UVT. And we would say by angle, angle, side, because that's the method that we used. Let's take a look at number 2 there, over to the right. I notice that I have an angle at A congruent to an angle at T, because they have the same number of marks. I notice that I have a side in between them, AC, congruent to side TV, and I see a third piece of information, another angle on the end, C and V. So looking at my order, I see an ASA, ASA, which is one of our 5 options. So I'm going to write a congruent statement that says what triangles I have congruent. So if I go with the letters here and I say triangle ACB, is congruent to triangle TVU. Now, if you put your triangles in a different order, like if you said ABC is congruent to TUV, that's fine as long as, again, the corresponding parts are matched up. I need to finish this by saying they're congruent by angle, side, that's not an S, angle, side, angle. So you're telling me what triangles are congruent, and then you're telling me how. Example, I need a different color here. We'll go red. Example 3. I notice that I have this side over here, RS, congruent to side TQ. They have the same number of marks. I notice ST has 3 marks, and so does QR. But that would only get me 2 pieces of information, and again, you always have to have 3. But notice that these triangles are touching, and they both share side RT. So that would mean RT is congruent to itself, which would allow me to get a third side. So looking at my order, I see side, 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 which again is one of our options. So we would need to write a congruent statement. And again, you want to be careful with the order of the letters here. So I'm going to start with triangle, my top triangle. I'm going to go R, S, T is congruent to triangle T, Q, R. And this time it was bi, side, angle. Why do I keep doing that? I apologize. Side, side, side. Getting excited here about our different theorems that we can use. All right, take a second for number 4 for me. Mark up the picture with your letters, your A's or your S's, and then take a thought about whether or not these 2 triangles would be congruent. So I'm going to go ahead and pause the video so I can add my marks in. I want you to do the same thing and then press play when you're ready to see how you did. All right, so looking at this, I noticed that I had sides on the end that were congruent. I had sides in the middle here, VT and XT, and then they have a pair of vertical angles around T that are congruent. So looking at my order, and again, starting in one corner and working my way towards the other end of the triangle, I see side, side, angle, and likewise for this other shape, I have side, side, angle. And if I look at my list, side, side, angle, or angle side side, like we set up above here, is not an option. So therefore, we'd say these 2 triangles are not congruent. So yes, they have 3 pieces of information, but it's not 3 that would force these triangles to be congruent to one another. And if you even look at these 2 triangles, you can tell that they're not identical to one another. There's pieces that are off. All right, last 2. Number 5 down here. So DE, I see a side, so I put an S by it. Corresponds to GF, put a side by it. Angle E is congruent to angle F, and I stop and I say, okay, that's only 2 things, but wait a second. These triangles are touching. They both share side EF. That side would be reflexive, so that's where I can get my 3rd piece of information. And now if I look at my order, I see a side, an angle, and a side. And then the other triangle, a side, an angle, and a side. And we know from up above, side, angle, side is a congruent statement that works. So I have to write my sentence first. So I'm going to say triangle. And again, if I follow the order that I went in, how I went like side, angle, side, I would start with triangle DEF is congruent to triangle. This time it would be GFE. By, and this time we use side, angle, side. All right, and our very last one that we have going on here, I notice my side marks first. So RS is congruent to TQ. I notice that I have a pair of angles, and I'm stopping and saying, okay, that's not enough. It's only 2, but wait a second. Those triangles are in fact touching. They have a reflexive side here, so that would get me my 3rd piece of information. But now if I look at this, be careful, this would not be side, angle, side, because notice it's going side, it's got an angle, and I'm skipping this top side, and I would jump to the middle. So it's actually side, side, angle, or angle, side, side, which we said we cannot use. But there's a right angle here. So remember, the option you have if you have a right angle is you have to check and say, okay, are the hypotenuses congruent, which would be the side across from my right angle, And in fact, that's the reflexive side. So here would be my H right in the middle. And then I would need one pair of legs congruent. Well, I marked this with an S, but this would really be an L because it's a leg. And same thing here. This leg would be congruent. So these two triangles are in fact congruent to one another. We just have to write a final statement out here and then we're done with 4.2. So I'm going to say triangle. I'm going to start at the bottom here with R. I'm going to work my way around this triangle. So I'm going to say RST would be congruent. Now I got to be careful. I'm going to start over here and go TQR. And this time we'd say by HL, which stands for hypotenuse leg. So your big idea for today is these 5 theorems over here are super important. So you want to spend some time keeping your notes out, working on your practice problems, and always checking and saying, okay, do I see side, 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 angle, 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 side, or HL? And again, use the strategy of labeling the pictures with the A's for the angles, the S for the sides to figure out, okay, which of my 5 options do I have? If you run into either of these 2 options from up above, it's not going to work. And again, anytime you have questions, feel free to call your teacher over and we will be more than happy to help you. All right, see you next time.